Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, everybody? Today, inshallah, we're going to study integration. Integration, you have it in your textbook into chapter 12. We have only 3 topics to cover on this chapter. The first one is volume of revolution. So we're going to do that next of this topic. The second topic is integration of EX and LinX. And the last one of the types of integration, which is integration by recognition, which is the opposite or the inverse of the chain rule, differentiation of the chain rule. Let's start. This is a very simple topic, integration of EX and LinX. Basically derivative, because you know that differentiation and integration are reverse to each other, or inverse to each other. Derivative of EX is EX, and derivative of LinX is 1 over x. We know that from the chapter 5. So since the integration is the reverse process of differentiation, integration of EX will be EX plus C. Why we have to write C? So C, you remember that we called it integration constant. Integration of EX respecting to x is e power of x plus c. Because this integration is indefinite integration, it's without limits. The definite one, you have limits. So you're supposed to replace the values of the x which is given to you without writing the c, the integration constant c. And integration of 1 over x is len modulus of x plus c. Why are we supposed to use the modulus? Because sometimes in case of definite integration, if you have limits, sometimes if these limits with a negative sign, so you're supposed to use the modulus, these two lines we call them modulus, to change or to cancel the negative sign and write it as positive sign. Because you know that there is no len of negative value. So let's start with the first question, exercise 12b on the textbook, page 259. Question number 1. The question asks you to evaluate. Evaluate means to find the value of 2 integration from 0 to 6 of e power of x dx. So simply, keep the 2 as it is, and integration of ex will be the same thing, e power of x from 0 to 6. Once you have to replace 6 and once you have to replace 0. So 2 e power of 6 minus e power of 0. Any base to the power of 0 is equal to 1. So the answer is 2 e power of 6 minus 1. Same thing here. Integration of 1 over x based on the rule is len modulus of x. So it's len modulus of x from 1 to e. And remember, because this is definite, so we shouldn't write the plus c. In case only indefinite, we have to write plus c. So len of modulus of e minus len modulus of 1. Len 1 is equal to 0. And len with the e cancelled and only the power is left. So the answer is 1. Question number 4 on the same exercise. Find the area enclosed by y equals e power of x minus x. The x-axis, x equals to 1 and x equals to 1. X equals to negative 1 and x equals to 1. So one of them has to be a and the other one has to be the b on the limits of the integration. So you know that area equals integration from negative 1 to 1 of the function which is given to you, e power of x minus x dx. Now, you can integrate e power of x. The integration of e power of x will give you the same thing, and integration of x is x squared over 2. You remember that, you just add the power by 1 and divide it by the new power. Once you have to replace 1 and once you have to replace negative 1, e power of 1 minus 1 to the power of 2 over 2 minus e power of negative 1 minus negative 1 squared over 2. By expanding the brackets, e minus half minus 1 over e, because it's e power of negative 1, negative by negative is positive half. Negative half with the positive half, then the answer is e minus 1 over e, or with the common denominator, it's e and then e squared minus 1. Both of them completely right. Square units, of course. Find the area enclosed by, this is question number 5, of y equals 1 over x. This is A and this is B. Area integration from negative 6 to negative 1 of 1 over x dx. Integration of 1 over x is len modulus of x. Here, there is an important point. We are supposed to use the modulus because you have negative limits, negative 6 to negative 1. Then len modulus of negative 1 minus len modulus of negative 6. Len of 1 minus len of 6. Len 1 is cancelled, and the answer is len negative 6. I told you before, you shouldn't write the area in a negative sign, so we have to use the modulus of the whole thing. So it's len 6 square units. Let's start on the first topic that you're supposed to start with, which is solids of revolutions. Find the area. I'll give you 2 examples of same equation or the same curve. And this is the rule of the area that you studied before in semester 1, integration from A to B, y dx. And the volume, this is the new rule, pi. Pi stands for rotating about the x-axis. Limits are the same, but now you have to square the function. Why? Because now the shape is 3D shape. Before that, you was having 2 dimensions. Now you have 2 dimensions, 3 dimensions, so you're supposed to use squared. See, find the area enclosed by y equals x squared, x-axis, and x equals to 2. So the limits will be from 0 to 2. Then integration from 0 to 2 of x squared dx. Integration of x squared is x cubed over 3 from 0 to 2 because you have to add the power by 1 and you divide it by the new power. 2 cubed is equal to 8 over 3, and replacing 0 will give you nothing, which is 0. Then the answer is 8 over 3. If you want to find the volume of exactly the same shape, so imagine that this shaded area will be rotating about the x-axis, be forming a 3D shape. See how many dimensions we have. 1, 2, and 3. So 3D shape. 1, because this is the same. 2, which is the height, and the radius, which is 3. So 3 dimensions shape. Now volume, see, find the volume of the shaded area through 360 or 2 pi radian, which is the same thing, about the x-axis. So all the question that you're going to do on this chapter is only respecting to the x-axis. Okay, so volume is equal to pi integration from 0 to 2 x squared all to the power of 2. When you raise the power of power is multiplying, it's x power of 4. Limits from 0 to 2. Integration of x power of 4 is x power of 5 over 5 from 0 to 2. Then you have to replace 2. 0 will give you nothing, so 2 power of 5 is 32 over 5 pi cubic units. Of course, you can write the answer in terms of pi, or you can simplify the answer by replacing the value of the pi, which is 22 over 7, or 3.142. Now we're going to use the volume of revolution to prove that some of the 3D shapes rules. I will start first of all with the volume of cylinder. So basically you don't have this point on the textbook. By the way, this point you was have it before on one of the final exams from 3 or 4 years back. The volume of cylinder is pi r squared h. As you see, we have 3 dimensions. R is repeated twice, which is the radius, and the height, h is the height. The question said when the area enclosed by y equals to r. So the equation of the straight line will be given to you. X-axis and x is equal to h is rotated through 360 about the x-axis. A cylinder is formed. So this is cylinder with base radius r and height h. Show that the volume of the cylinder is v equals pi r squared h. This is the y-axis, x-axis, and this is the straight line equation. It's y equals to r. Why? Because the distance from the origin or the x-axis to the straight line is r, so it's y equals to r. And the limits of the integration will be from 0 to h. Now you have the cylinder. So this is a rectangle. When you rotate the rectangle about the x-axis, it will be forming a cylinder. Pi, we're going to use the volume formula. So this is the volume formula. Pi integration from a to b of y squared respecting to x. So pi integration from 0 to h of y squared dx. Now you're going to keep the pi as it is, limit 0 to h. Now y is r. You're going to replace the y as its equation, which is r, so r squared. R squared is a constant, you just keep it outside because it doesn't affect y, because you integrate respecting to x. Now integration of 1 respecting to x will give you x, and these are the limits. You keep the pi r squared outside and just replace the h. So that 0 will give you nothing, so it's pi r squared h. It's proved. Now let's do the volume of the cone. Show that volume of the cone is 1 over 3 pi r squared h. This part you have it in the textbook. The equation of the straight line that you needed to prove that or show that the volume of the cone is equal to this rule, the equation is r over hx. Now the shaded area combined or enclosed between the straight line, the x-axis, and the x equals to h. This is the straight line, x is equal to h. Good. Now the limits of the integration will be from 0 to h, as we did in the previous question. So show that the volume of the cone, a cone is formed with radius and height h. So the question will ask you to do that. Show that volume of the cone is pi r squared h all over 3. This will be the question. Good. Now volume, pi, limits of integration from 0 to h of, what's the equation? It's r over h x all to the power of 2 dx. Then integration from 0 to h r squared over h squared x squared dx. Now you have to move that outside. Why? Because it's a constant. So it's pi r squared over h squared, and then integration of x squared is x cubed over 3 from 0 to h. Keep the pi r squared over h squared as it is, and then you have to replace h only. So it's h cubed over 3. Squared, cancel the cube, so only 1h is left. So it's pi r squared 1h all over 3, or 1 over 3 pi r squared h. Proved. Let's do the same thing with the volume of the sphere. Volume of the sphere is given by the relation 4 over 3 pi r cubed. So the 3 dimensions are the radius. When the area enclosed by the equation, now guys, the equation has to be given to you in the question. X-axis is rotated through 360. About the x-axis, a sphere with radius r obtained. Show that the volume is equal to this. So volume, limits of the integration, pi, you keep the pi outside, is from negative r to r. See, these are the limits, negative r to c, locked to the shaded area. Then square root of r squared minus x squared all to the power of 2 respecting to x. Squared cancel the square root. When you raise the square root to the power of 2, they will cancel each other. Then you have pi negative r to r of r squared minus x squared dx. Now we have one important point. If the limits are the same, so distance from negative r to 0 is the same as from 0 to r. So you can do it once and you double the integration. So you can write here 2 pi 0 to r of r squared minus x squared dx. Now start to integrate. Keep the 2 pi as it is. Integration of r squared is r squared x. Don't say r cubed over 3, because you integrate respecting to x, not respecting to r. Minus, now you have to raise the power and divide it by the new power from 0 to r. Now you have to replace the r. Keep the 2 pi as it is. R squared times r minus r cubed over 3. Then 2 pi r cubed minus r cubed over 3. You can take r cubed as a common factor. Then you have 1 minus 1 over 3. 1 minus 1 over 3 is equal to 2 over 3. So 2 over 3 times 2 is equal to 4 over 3 pi r cubed. Then it's proved. Exercise 12a on the textbook, page 255 and 256. We're going to start this exercise directly from question number 4. Why? Because the questions from 1 to 3 are talking about the area. So those areas are related to what that we did in semester 1, and they will never ask you about anything related to semester 1 on the areas. But they will give you area of E, area of 1 over x, which will give you len, and area of the sum of the functions, which you have to integrate it using integration by recognition. These only the areas that you need them on this chapter. As you see, y equals 9 minus x squared, but we don't have the limits of the integration. As you see, the shaded area started from here to there. These 2 points, we call them x-intercepts. How did you find the x-intercepts? So by writing y equals to 0. This step is to find the limits of the integration. Y equals to 0. So 9 minus x squared equals to 0. You just move one of them to the other side, and then you take the square root of both sides. X is equal to positive and negative 3. These are the limits of the integration. Then you're going to use the formula of the volume because it's required to find the volume. Rotated through 360 about the x-axis. Volume is equal to pi integration from negative 3 to 3 of 9 minus x squared all to the power of 2 dx. I told you if you have the same limits, one of them is positive and the other one is negative, you have to double the integration and start from the 0. So 2 pi 0 to 3. Now you have to expand the brackets, square the first, which is 81, square the last, which is x power 4, and midterm is first by second by 2, which is 18x squared dx. Here is the rule. A minus b squared is a squared minus 2ab plus b squared. Now you have to integrate. Integration of 81 is 81x, and then 18x cubed over 3 plus x power 5 over 5 from 0 to 3. Now you have to replace 3 without using the 0 because 0 gives you nothing. 81 by 3 minus 18 divided by 3, 6, then 3 cubed plus 3 power 5 over 5. We're going to use the calculator to get the accurate answer. 2, because you're going to keep the answer in terms of pi. 81 by 3 minus 6 by 3 cubed plus 3 power 5 3 power 5 dividing by 5. So the answer is 1296 over 5 pi cubic units, because we're talking about volume. We still have the same question. This is question 4D. And the straight line equation is 2x plus 3y equals to 6. It's required to find the volume of this shaded area if this shaded area is rotated through 360 about the x-axis. We're supposed to find the limits of the integration. We can find the volume using 2 ways. The first way, using the normal integration from 0 to this point. So this is x-intercept. How did you find the x-intercept? You know that y equals to 0. So 2x plus 3 by 0 equals to 6. Then x is equal to 3. Because when you divide both sides by 2, 2 divided by 2 is 1, and 6 divided by 2 is equal to 3. Now, we're supposed to do one thing to the equation. We have to write y in terms of x. 3y equals to 6 minus 2x, and you divide both sides by 3. Y equals to 6 minus 2x all over 3. So volume, let's call that y1. Volume equals to pi integration from 0 to 3 of 6 over 3 minus 2x over 3 all to the power of 2 dx. So we have to split the denominator to make it easier. Integration from 0 to 3, it's 2 minus 2x over 3 all to the power of 2 dx. Now you have to square that. Integration from 0 to 3, squaring of the 2 is 4. First by second by 2, which is 8 over 3x. Then the last term is 4x squared over 9 dx. Now you have to integrate. Integration of 4 is 4x. Then 8 over 3 x squared over 2. Then 4 over 9 x cubed over 3 from 0 to 3. You have to replace only 3. 4 by 3 minus 8 over 6, because 3 by 2, and then 3 squared, plus 4 over 27, 3 cubed. Let's do that using the calculator. It's 12 minus 8 over 6, multiplying by 9, which is 3 squared, plus 4 over 27, multiplying by 27. So the answer is 4 pi cubic units. So the second way, we're going to find that volume using volume of cone. Why? If we just back again to the same question, this shape is a right angle triangle. So when the right angle triangle is rotated through 360 about the x-axis, it will forming a cone. Okay, so we're supposed to use volume of the cone. Volume of the cone is 1 over 3 pi r squared h. V equals to 1 over 3 pi r squared h. Now we have to find r and h. Let's back to the question. This is the h, which is the height, and this is the r, which is the radius. So the limits from 0 to 3, so this is the height and the radius. We're supposed to find the y-intercept. So from the equation, how do you find the y-intercept? By replacing x as 0. So y equals 6 minus 2 by 0 over 3, which is equal to 2. So radius is the y-intercept, which is 2, and height is the x-intercept. This is y-intercept and x-intercept. Now let's replace them directly. 1 over 3 pi, and r is 2 squared, and the height is 3. 3 cancel 3. 3 divided 3 is equal to 1. 2 squared is 4, so it's 4 pi cubic units. And we got exactly the same answer. Question number 5. Find the volume of the solid generated by rotating through 360 about the x-axis of the area bounded by these lines and the curve. This is the equation of the curve, which is given to you, and y equals to 0 is the equation of the x-axis. This is the x-axis, and the limits, as you see, from 0 to 2. I know the sketch is not given to you because the question asks you to sketch the graph. By the way, in the final exam, they will give you the sketch ready on the exam paper. So directly, volume, pi, integration from 0 to 2, square root of x all to the power of 2 dx. I told you before, squaring of the square root, they will cancel each other. Integration from 0 to 2 of x dx. Integration of x is x squared over 2 from 0 to 2. You have to replace only 2, so it's 2 squared over 2, which is 4 over 2. Then the answer is 2 pi cubic units. Here we go again, last question. Question number 6. The diagram shows part of the curve y equals x squared and y squared is equal to 8x. So this curve is y squared equals to 8x, and this curve is a part of y equals x squared, the parabola. Find the coordinates of the point A. A is the intersection point. How did you find the intersection point? By equating both. So you do y equals to y. So we're going to write that. The point is we're going to replace y. We don't have y, it's y squared. So you're going to replace that. On the equation of y squared equals to 8x, we replace y as x squared. So it's x squared all to the power of 2 equals to 8x. Move that to the other side. X power 4 minus 8x equals to 0. You don't have that on the calculator, but you're supposed to take x as a common factor. So x cubed minus 8 equals to 0. We'll find two values of x. X equals to 0 and x is equal to 2. Because cubic root of 8 is equal to 2. We're going to continue that we did in part A because the space is not enough. So we reach to the step x cubed minus 8 equals to 0. Once x equals to 0 and once x cubed equals to 8. By taking cubic root, x is equal to 0 and x is equal to 2. Don't write at all positive and negative. This is only for the even roots. So the point which is required to find is x is equal to 2 because 0 and 0 is the origin points. So how did you find the y? By replacing that in one of the equations. One of the equation is y equals to x squared. So y equals 2 squared, which is equal to 4. Therefore, the coordinates of the point A, 2 and 4. Now we're going to continue on part B. Calculate the volume. So remember that as we did in the area, any shaded area between two curves or curve in a straight line, we have to do top minus bottom. So we're going to do the same thing, but you have to square each one individually. So the volume of enclosed volume of area enclosed by two curves, pi integration from A to B, y1 squared minus y2 squared, or you can say that top squared minus bottom squared. From the shaded area, this is the top and this is the bottom. You can state that is easily top is the upper part of the shaded area and bottom is the lower part of the shaded area. So you do volume equals to limits of the integration from 0 to 2 because we got that from the previous point, from point A. So volume pi integration from 0 to 2, top I told you is 8x, and it's already, by the way, it's y squared, so no need to square it one more time. This is only for the y power of 1. So you're supposed to write it as it is, 8x minus x squared all to the power of 2 dx. Now, why we didn't give power of 2 again here? Because it's already y squared, but the other one hasn't power of 2. So it's pi integration from 0 to 2 of 8x minus x power of 4 dx. Pi integration of 8x is 8x squared over 2 minus x power of 5 over 5 from 0 to 2. You have to replace only 2. 8 divided by 2, 4. 2 squared minus 2 power of 5 over 5. We can do that using the calculator. First part is 16 minus 32 over 5. And the answer is 48 over 5 pi cubic units. Thank you.